Alright, these are two exponential functions that are very common. We have our exponential growth function and our exponential decay function. There's growth, growth and decay. The exponential growth function, when you graph those, they always look like this. Now you can move that line around. That line could actually be down here, or it can be up here. It all depends on the situation. But the exponential growth function always takes off. It looks like a plane, in my opinion, like taking off. The exponential decay function is quite the opposite. Instead of taking off, it lands. So an exponential decay function would look like this. And just like the exponential growth function, you can move it around. Now in our functions, in our formulas right here, the A represents the original amount. So whatever situation you're presented with, A is the first, the beginning amount. The R is your rate. Normally this is given in a percent, but make sure you always write your rate as a decimal for your formula. And then T is your time. Most of the time this is given in years. So let's check out this first problem right here. You buy a new car for $46,000. That's going to be your original amount. The value of the car decreases, that's important to know, by 15% every year. Okay, so which formula would you use? You would use the decay formula. Why? Because this right here, the value of the car decreases. So we're going to use the decay formula. So let's write that down too. F of t equals a 1 minus r raised to the t power. Over here it says in B, write an equation to model the value of the car after t years. Okay, so for this part, all we have to do is plug in the values that we know. So we don't know t because it says after t years. We do know the value of the car. The value of the car is $46,000. We have 1 minus r, and r is our rate. And since it's 15%, we're going to put 0.15. You always move the decimal twice to make it not a percent anymore. So like if it was 6%, the decimal for that would be 0.06 because you have to move the decimal twice. And then t goes right there. And then we can actually simplify this a little bit because you can subtract 0.15 from 1. So if I go 1 minus 0.15, I'm going to get 0.85 t. If you forgot how to do the decimals, don't forget the 1 has 2 zeros after the decimal if we put a decimal in it. So this is the 1. Then we subtract the 0.15 from it. And you'd have to do some borrowing and stuff. Let's see, it's borrowed from this 10, make that a 10, so it's a 5. 9 minus 1 is 8. Put the decimal there. There's your 0.85. So here's our formula for a situation. C says evaluate the value of the car after 8 years. And so here we're plugging in the 8 for the t. Now right there you're just plugging in 8. All this says is I'm plugging in 8 into the f function. You don't actually do anything with it. The f is not multiplying to 8 or anything like that. Then you plug it in, so you got 46,000, 0.85 raised to the 8 power. Now don't forget your order of operations here. To do this correctly, you have to do the power first. So we're going to raise 0.85 to the 8 power, and then after that we will multiply it by 46,000. So let's write 46,000 right here. Then I'm going to raise this to the 8 power. But after I get the number, whatever number it is, I'm not going to clear it from my calculator because it might be a really nasty decimal. And I don't know. I haven't done it yet. So here, let me punch it in my calculator. Oh yeah, that's a really nasty decimal. So we got 0.272. And I suggest that you try this on your own to see if you get the same number as I do, so you know that you're doing the power correctly. Now, on your iPhone, the button that you want to use, I think it might be the same for the Android. If you want to say 0.85 to the power of 8, you get to use a button that looks like this. It says x to the y power. So you would push 0.85, and you'd push this button, and then you would say 8. That would raise 0.85 to the 8 power. Okay. Then after you say equals, leave that nasty number in there. Now I simplified, or I rounded it, but leave that number in your calculator and just say times 46,000. So that's 12,534. I'm going to round it at 56. The next number is 4, so I'm going to leave 6 as 6. And the reason why I stop right there is because we're talking about dollars. And we always go to the second decimal place when we're talking about dollars. So this says after 8 years, the value of the car is going to be $12,534.56. The next question says, is your answer to C reasonable? Why or not? Now that's pretty crazy when you think about it. A $46,000 car depreciates in its value, decreases in its value down to $12,000. Wow. That does sound reasonable. I'm not a car expert, but it does sound reasonable. I'm going to say yes because the value of new cars drops dramatically after you buy it. Almost ran out of space there. Oops. I do know that part. That's why it's never good to buy a brand new car. It's always better to buy a used car because you're not going to lose as much money after you purchase it. Alright, so just a quick recap. If you're talking about exponential decay, it's 1 minus the rate. If you're talking about exponential growth, it's 1 plus the rate. And if you guys remember the vampire stuff that we did, that was exponential growth. We found our formula a different way. We didn't use this formula, but you could have used that formula to find the number of vampires that we were doing in our activity. But anyways, I hope this helps.